going here.
Yeah.
Now we're going?
We'll have to trim the front.
Good evening and welcome to the October meeting of the St. Louis Java User Group. I'm Zachary Klein. I'm one of the members of the JUG steering committee, along with a few others that we'll see in a moment. A little bit of history on our group. I'm not going to read all of this like our esteemed leader usually does. Most of you have been here before, but we have been around since 1997. Attendance is, of course, free, so please come or join us online if you can. We typically begin our meetings with food and socialization time at 6 o'clock, with our presentation beginning at 6:30. And our normal meeting location is right here. So congratulations, you found us. We meet here at the training room at Object Computing, where I work. And of course, we stream this online, and it will be uploaded to YouTube shortly after tonight as well. Here's the rest of our steering committee, both from left to right. Myself, Zachary Klein. We have Bruce Alsbaugh. We have Robert Levitt, and Ted Doyle. And we're all here tonight, so that's great. And we are looking for more help on the steering committee, especially if you live here in St. Louis. So if you'd be interested, it's not that much work. Hit us up, and you can help out with just keeping this meeting going. And there's little logistic things that we have to take care of, but really it's not that much work. So please do reach out if you'd be interested in helping. Our sponsors include, of course, Object Computing, my employer. They've been sponsoring the JUG for a long time. Manning, the publishing company, they sponsor ebook giveaways at most meetings. JetBrains, and then our friend Lee Bobbitt has graciously sponsored our meetup subscription. So thank you very much. We really appreciate that. It's surprisingly, it's probably our biggest single expense, I'd say, as a group, is our meetup fee. So we greatly appreciate that. And we have an ongoing discount for Manning ebooks, 40 ebooks or paper books as well?
Yes.
Okay, Dead Tree versions are included. So 40% off any product, use the JUG 13 discount code. What is 13 for? So is this a code from 2013? And how long has this been going? All right. Okay, moving along, upcoming presentations. So next month, November 13, we will have, I can't pronounce that name, Hao Yo Lee, something like that. Simpler Java build tools with object-oriented programming. I believe that's a remote presenter. Is that correct? He'll be here from Singapore here in St. Louis. So that's awesome. So please be here if you can. And upcoming presentations. Okay, so you can watch our meetup page for updates on upcoming presentations, and then check out Bruce's YouTube channel. We got to get an official channel at some point. But check out Bruce's channel for recordings of past presentations going back to, I think, 2020, 21, right around there. Yep, since COVID. That's right, AC. Okay. And if interested in giving a presentation, please reach out to us at our Google Groups address. Is that still current, Bruce? Okay, very good. We welcome any submissions, any ideas, and be creative. If it's not a full-on talk, if you just want to have some sort of an open discussion on a topic that you want to have us facilitate, something like that, let's brainstorm. Give us those ideas. We definitely will be receptive to that. All right, tonight's presentation, what's next for WebAssembly on the server by Harry Kimpel of New Relic. New Relic sponsored the pizza this evening, so thank you, New Relic, for that. Very gracious. And I think that's the end of the slides. Did I miss anything, Bruce? Did I do it? Am I fired? Am I all right? Okay. All right. Harry, I'm going to turn it over to you now.
All right. Flip on your mic here.
Yeah. Can you hear me?
Right.
Yeah, you can hear me on the recording as well?
Yeah.
Perfect. So let me switch over to the slides. So welcome everyone. What's next for WebAssembly on the server and how to see it in action? That was actually a talk I gave at another conference here in the US. I slightly adapted it specifically for this user group here to make it more specific. But we'll go through the details in a second. Who am I? My name is Harry Kimpel. I'm a principal developer relations engineer at New Relic. This is also the area I live in. This is in southern Germany, in Bavaria, at the border of Austria, basically. So behind these mountains, we have Austria already, and a little bit further down, it's like Italy. This is also my skiing area right here, and I hope the skiing season opens pretty soon. Anyways, this is the highest elevation of Germany, the Zugspitze. I have been in software development pretty much all my professional career. I know that this is a Java user group. I started in the Microsoft developer ecosystem. Don't judge me for that. I'm sorry, but I have worked with Java as well in my career. It's coming up on 30 years almost since I'm in IT. So I have seen quite a bit. I started in, professionally writing code in Visual Basic 3 and Visual Basic 4, so a long time ago. And I'm with New Relic since 2017. Worked slightly in a different capacity. Was a solution architect before at New Relic, and then switched over to the developer relations team, which I very much enjoy doing. And if I'm not in front of a computer, I like all things outdoors, as you can imagine from this picture. Hiking, biking, climbing, skiing, of course. I live there with my family. It's a small village I live in. We only have like 3,000 people in the village. But I have pretty good internet connection, which is the most important thing. And my kids also enjoy it. I have 3 kids and live there with my family. So really enjoy that. I guess no talk these days without some form of AI. So I recently asked ChatGPT, based on what you know about me, and you may know that it has some memory functions. It knows what prompts you asked and what results and what you do. And so it learns from your experience. I asked it, based on what you know about me, draw a picture of what you think my current life looks like. And the response I got was this. Here's an illustration capturing your developer's life, inspired by the Bavarian Alps and stuff. So quite nice. And this is the picture I got back. And I thought, this is amazing. This is amazing. You can tell from the mountains, as you've seen previously, this was a live picture I took a couple of months back. You see the mountains. Even the houses look very similar to this, as very typically Bavarian housing style. Draw a desk with some monitors. My little daughter, she's 12 years old. She asked me then, how does ChatGPT know that you have so many monitors at home? I do have a lot of monitors. And I'm like, I don't know. It maybe assumes that developers have lots of monitors. I don't know. But what I also found interesting that on the monitors, it also draws some observability dashboards on the screens. And I think this is just an amazing picture. Anyways, let's get into the topic. WebAssembly, or Wasm for short, on the server. Why is that important? And some aspects that I want to go through today. And please, if you have any questions, if you stop me anytime. I'm not a Java specialist per se, so you saw it previously, right? But I, have a couple things to share, which are some are not Java related and some are Java related specifically. Basically, some WebAssembly history. It originated in 2017 as an MVP, minimal viable product. Demand for increasing, performance on the web pages. You probably have all seen various kinds of plugins, Flash. I worked with Microsoft Silverlight, which is, I'm glad it's gone. But anyways, Java applets, Adobe Flash, Microsoft Silverlight, and so on and so forth. The point is, they were all running in the browser, right? The focus was to run these applets in the browser to help, perform some actions, run some applications there. The design goals of Wasm was, first of all, or WebAssembly was, it should be fast, predictable, and near native execution time. That was the most important things from the first perspective. Secondly, it should be safe. It should be designed for efficient, secure verification and isolation of untrusted code, right? We all have seen various kinds of things running in the browser, and then things get injected, and it's not secure, and you can hijack things. So one of the other purposes was really it should be secure, whatever you run in the browser. It shouldn't have access to your file system or to other things on your computer. It should run in a sandbox environment. Hardware independent, of course, it should run on all different kinds of hardware. Even in this room, we see a lot of different, hardware, MacBooks, laptops, Windows, operating systems. So it should run on any hardware, but also on any kind of, browser environment. And lastly, one of the core things also, it should be web language independent. So ideally, the idea was that you can write WebAssembly in any language and compile it into WebAssembly, and then make really use of the benefits of running WebAssembly in the browser. Then on top of that, at some point, since it had the focus on securely running things in the browser, it was also locked down quite heavily. And this is where the WebAssembly system interface, or WASI, comes into play, because what they do is they have realized, and this is in 2019, so 2 years later, that the Wasm design goals could also benefit things on the server side. And so that is where WASI comes into play. It defines an interface that Wasm runtimes can implement. So you can implement these interfaces so that you can have defined connections outside of your WebAssembly to other sources, to making web calls or other things. And it should enable communication with operating system, or running something outside of the web in some other shape or form. So this is the WebAssembly system interface. And again, it should realize that ideally this could also benefit things on the server and not just on the browser in your client environment. And I think this quote from Solomon Hykes, the founder of Docker, which I find really interesting. He mentioned that if Wasm and WASI existed in 2008, when kind of like Docker was hyped and started, and everything went to containers, we wouldn't have needed to create Docker in the first place. That's how important this WebAssembly on the server is the future of computing. That's one of his quotes. I think it's really a tough one, and maybe not sure if everything will run as WebAssembly in the browser. There's probably some use cases, but I think it's an interesting quote from Solomon that he mentioned here. So then this brings us into Wasm outside of the browser, or on the server side, and this basically it needs a runtime. So basically, if you want to run WebAssembly on the server side, you may know that in your browser, in your Chrome, Firefox, Google Chrome, or Edge, they already support WebAssembly since a couple of years then. But if you want to run WebAssembly on the server side, you need to have some kind of Wasm or WebAssembly runtime to run these applications. And so one aspect is, you can use Docker and Wasm. The technical preview was released in 2022. And this is one option to run WebAssembly. And then typically on Docker desktop, there's a couple things that you can install. And these are just some examples of WebAssembly runtimes that you can use when you want to run WebAssembly in containers. Yes, Spin, for example, I'll cover this as well later on. There's Wasm Edge, Wasm Time, some others. So there's a couple options that you have on defining how do you want to run your WebAssembly in containers on the server side. One of the things on how this could look like is, and this is a really basic example, this is written in Rust. So again, this is just like one line of code. It prints out, hello, St. Louis JUG. The Docker file is really interesting if you want to run this specific WebAssembly application in Docker. Of course, you need to compile this Rust code into a Wasm file. But once you have that, the Docker file, it starts literally from scratch. You don't have to use any kind of operating system like Node or Rust or anything where you already have a lot of dependencies that you bring in. It literally starts from scratch. And then I copy in my WebAssembly file, and then define the entry point to be the Wasm, the WebAssembly file that I created from this little Rust program. And then if I want to run this application, I can use the plain Docker run command that you see here. And then I define the platform on what the Docker environment should use as a platform for this container. And then I can also define the runtime. As you've seen previously, there's a couple runtimes that I can use. In this case, I'm using Wasm Time as one of the runtimes, and then define the name of the Docker container that I want to run. Of course, I built the Docker container first based on the Docker file that we have seen. And then, as you can imagine, in the Rust application, it was only a print line, so it printed out the the line of code. So this is how easy you can use Docker and WebAssembly in some form of containerization aspect. Any questions so far? So then there's, of course, other runtimes that you can use. Spin is another option. It is kind of like a developer tool for building WebAssembly, microservices, and web applications. And this is kind of like their screenshot from their website. It typically has a couple different CLI commands. So they have their own CLI that you can use to create new WebAssembly applications. You can build them with Spin, and you can also run them with this command spin up on your machine. So really, they have developed and looked into some really nice aspects of how to make it easy for developers to get started using WebAssembly components and implement them. And this is also a really interesting aspect. Spin in combination with another tool called Spin Cube is an option. It is part of the CNCF Foundation these days. And it leverages some dedicated shims that you can allow you to run Spin workloads in Kubernetes. And so you can define some Spin Cube runtimes and environment and node configurations on your Kubernetes cluster, and then Spin in combination, like Spin developing your WebAssemblies and Spin Cube to run your applications in Kubernetes. You can use that to natively run WebAssemblies in your Kubernetes cluster, which is a really interesting concept. There's a lot of discussion currently going on with Kubernetes, and everyone's hyping this. Probably not as highly hyped as it used to be, but still Kubernetes is one of the core runtimes these days. Another option for WebAssembly runtimes is Wasm Cloud. This is also an open source project, also part of the CNCF Foundation. I think there's no standardized environment in this as part of the CNCF Foundation these days on how they say, if you want to run WebAssembly on the server, use this tool. No, they have a couple different options. Wasm Cloud is another option. You can also build applications composed of reusable WebAssembly components using Wasm Cloud and run them across any cloud, in Kubernetes as well, in data centers, or on an edge component. They also, Wasm Cloud also comes with a CLI that you can use, Wash. It's interesting how they define the names of the CLIs. But Wash that is a command to create your new WebAssembly component that you can use. And then they have a platform that they provide as a SaaS service. The company behind Wasm Cloud is Cosmonic, and that allows them to, you can run, send them your Wasm Cloud component, and they run it for you, or you can run it offline, using some of the CLI command that we've seen. So the different options that I provided here, first, Wasm time. It is really a fast and secure runtime for WebAssembly. And it's also, there's also this project called the Bytecode Alliance, which defines some concepts around, WASI, for example, and Wasm, like the features and functionality of WebAssembly. This is one option. And, the features for Wasm time, is really, there's a lot of, cloud vendors involved. You can configure them. So really highly, able to create, easily some WebAssembly components using Wasm time. As with any other options that you have seen so far, they also provide, a lot of different languages. Rust, Java. It should have probably looked into. This is probably a couple months old. Whether Java made it on this list yet, I need to double check this. But at the point, this is like 2 months back. Wasm time did not support Java yet, but they have a lot of other languages that they support. So interesting concept. And I showed in a couple of seconds on what the options are for Java specifically. And then this is one example showing some Wasm component. This is now using .NET in this example. You've seen my background, so used .NET here, C#. This is it looks, C# and Java, they look very similar if you compare them one-to-one. You should probably just, compare this one-to-one into Java almost, some different concepts, but it's a main class. This is a console app that I created here. What's interesting here is, and independent of the language that I used here, C# in that case, there's a component here that I'm loading from a text file. This is the gcd.wet file. So what I do here is I use plain C# code and then incorporate, and of course using Wasm-time, I incorporated Wasm-time as a dependency. And then I'm using a text file that I embed into my application. And what is this really? And the solution here is this is the gcd.wet file that I used, and it's almost readable, right? It's code that is written in a so-called WebAssembly text format, and the whole purpose is that WebAssembly text format, this wet file that I used and embedded into my C# code, is a WebAssembly is a binary format and is compiled, right? But you can also use WebAssembly text format for building, for development, because it's way easier to identify what is happening in a WebAssembly component, and then you can also run this WebAssembly text format in your application and embed it into your other forms of applications. Yes.
So basically, what you've got is it's a virtual machine, and it executes this bytecode, which we call WASM.
Mm-hmm.
And the WAT is the human readable. It's like the assembly language for the virtual machine bytecode. So
basically, yes. So you can see, this is the WebAssembly text format, and you can see there's some functions that you define. You define some parameters here. So this is a function definition, and then you do some code, and I mean, the point is this is almost human readable, right? It's not like as easy as a higher language like Java, but it is something that you can identify what is going on. It's kind of like assembler yeah. But the point is you can run this then as part of your application and embed this into your Java.NET C# file, and run it and test your WebAssembly application.
So is it a register-based virtual machine? Is it a stack-based machine? What kind of virtual machine are we actually looking at?
So in this case, what I used is a WebAssembly runtime called Wasm-time. This is kind of like your virtual machine, if you will. It's not like a JVM in that sense, but this is using Wasm-time as your runtime, and they have SDKs in place on how you can embed WebAssembly text format into your code base to have a human readable format that you can look at and debug easily.
So it'll actually compile. You can have it pre-compiled, but it can also compile the source code as part of its execution.
Exactly. It's just a different option. You would probably not use this in production, but it's easier to debug. It's editable. You can edit this text file, on the fly, and have it already almost immediately, updated in your application.
So you got what looks like data types in your previous slide example. You got like an I32.
Yes.
Like what are your basic data types that you can work with? I gather you have like booleans. You have Unicode characters, maybe.
Yes. Yeah. You have the
strings,
all the basic
sort.
strings, the integers, doubles,
Arrays.
floats, arrays. Yes.
Okay.
Yeah.
Any other types of structures?
I think when it comes to structures, it's almost it ends at that point. I think it's more like simple, data structures that you can use, and not like more complex ones.
Okay.
Yeah.
And it's also more than just like a bare hardware machine, because there's a garbage collector in newer versions of it, because I don't know what your memory model looks like. Because it was a linear thing before, and then now they've added Wasm-GC,
yes, yeah,
which works better for garbage collected languages. So if you're going to compile like C# or Go or something like that requires a garbage collector, you don't have to download a garbage collector into the machine. It's got one already built in.
exactly. Yeah. So your build, the WebAssembly build, is way smaller because you don't need to include this into your application. Yes.
The idea is to minimize the download time especially for a browser-based application, because you don't want to download a humongous
Exactly.
runtime.
Yeah. And I get to some statistics later on where I compare, typical applications and the size of the builds.
Okay.
Yes. Yeah.
Interesting. All right.
So I think this is just another interesting aspect of WebAssembly, that you can also use like a text format and play around with it and use it in your applications. Why would you write it? Yes, being able, it might explain some code better. You need to debug some code. So it has some advantages, but it's probably not ready for prime time when you want to run this in production. This is more for like development, experimentation formats. Let me get my... And then there's another aspect called or environment called Golem that you can also use. They also have components on how that allow you to build applications, like a CLI that you can use to build WebAssembly applications, run them. They have also a runtime environment, a SaaS service where you can deploy your WebAssembly files and they run it for you, or you can run it also locally in your environment. So really lets you build and deploy the applications and, with a simple CLI environment. So these are a couple examples that I showed for WebAssembly runtimes. There's probably more out there, and it constantly changes.
Can you use Node.js as one of your runs?
If I can,
I thought Node.js can run Wasm, can it not?
so are you
Node.js?
talking about like writing WebAssembly in Node.js?
No. Using Node.js to execute, because it's got a runtime embedded in the Node.js runtime, is it not?
It does. It is possible to run, for example, npx and spin up like an HTTP server and run your WebAssembly. Right. Yes, correct. Yeah.
Yeah, but why would you want to use Node?
Because maybe you're already familiar with it.
Yeah. I mean, again, there's probably more runtimes that you can use. This is just a section of it, but we looked into Docker, and I showed a very simple example on running WebAssembly in Docker. Spin as one example, and especially in the combination with Spin Cube to run them inside of a Kubernetes cluster. Wasm Cloud and Wasm Time as two other forms of runtimes for your WebAssembly. So how does it look like for Java specifically? And you mentioned also, I'm not sure how to pronounce it, Chirpj. Okay,
Yeah.
Thank you. As one option, I did a little bit more research on what other options are out there specifically for Java. And in general, there's what I found, these two different concepts. So there's one concept to use WebAssembly with Java when it comes to ahead of time compiling, where they use bytecode to WebAssembly. So basically, you would create, as we have seen previously with this little Rust application, where you create a Wasm module that runs in the browser, with WebAssembly garbage collection or JavaScript interop, or you can run it on servers via Wasm runtimes that we have seen already, like Wasm Time or Spin, that you can use. So it is possible to use ahead of time compiling with Java and run these WebAssembly files on the server or on the browser. The tools that I identified are these three. They all come with different options: TVM, bytecoder, JWebAssembly, and Graal VM. They all have, slightly different features and capabilities, but it is, possible to run or to compile your Java environment to WebAssembly using these tools. You mentioned as well, some aspects like, how is connectivity? How can I talk to other services? Is Java.NET, for example, available as a package in WebAssembly? Can I use database connections, ORM, and so things like this? And these are all, some of these things are possible if you can, embed, or if there's packages that exist that compile into WebAssembly. in some of the use cases, it's simply not possible today to, for example, connect directly to databases, mostly because of the lack of possibility to have multi-threading in WebAssembly these days.
Oh, you can't multi-thread this
No,
machine?
no. I mean, not if you use the WebAssembly module, if you compile it into actual WebAssembly. The other option is, and this is the JUG option, and this is, they come with a JVM that allows you to run your Java application in this JVM that is built as a WebAssembly module. So basically, they have a slightly different concept. So you would ship a Wasm-based JVM. This is what JP provides. And then it executes your Java class files at runtime. There's no ahead of time compiling for your app. The tool is JUG. I think there's a company behind. I forgot the name. Need to double check. But basically, the best use case for them is kind of like if you want to do a lift and shift. If you have like your Java application and for some reason you want to run it in the browser on the server side as a WebAssembly module, you can do that. And the purpose or the main purpose is to run desktop or applets in the browser, or if it's not like a browser application, like on the server side. So there's two different concepts. They all have their pros and cons. I think if you want to be a little bit more flexible, you would probably go the route of using JUG because you have more flexibility, broader support for your packages, and it almost supports everything that a typical Java JVM would support. And then on the other hand, if you want to really compile Java into WebAssembly, there's a lot of restrictions these days that you have to deal with. Not all packages are available. For example, java.net is not available out of the box. ORM mappers are probably not working for various reasons, multi-threading being the most important one. So there's a couple different nuances that you can use. Yes?
Can either of both of these models use REST calls?
So they, yes and no. So in some occasions, you are restricted on the WebAssembly front to the libraries that are supported in WebAssembly. It uses also the WebAssembly system interface to connect to other services. You need to open up the ports, and you need to provide, you need to define what it is that the WebAssembly module can talk to. So you need to be proactive because you need to open up these things proactively. On the front of the Wasm-based JVM, you are a lot more flexible to make calls to other services and REST calls. So it's probably a little easier. And most of the,
what I was thinking is you make a REST call, and the REST call then talks to the database.
Yes, that's a typical use case. Yeah, you make a call to some other service that then makes the connection to the database. That's the typical use case. Yeah. Yes.
I understand it's possible to ahead of time compile Kotlin source code directly to Wasm assembly code.
Yes.
But you're saying that this chirp doesn't do that. It's just like an interpreter for the class.
Yes.
Okay.
Yeah. But you can use, for example, Java, Kotlin, Scala to compile into WebAssembly. That is possible. Yeah.
That's what I would probably want. But I do it on the other side.
Yes, probably. Yeah.
With
well, if you have a component that already is built, like a compiled into a jar file, I guess it doesn't matter if it's Scala, Kotlin, or Java. And the JVM could probably run it as well, right? Yeah.
Yeah, I mean, once it's bytecode, it's bytecode.
It's bytecode, exactly.
The source.
Exactly. Yeah.
But if you want to, but if you're starting with Java source code, you want to use one of the tools on the left.
Yes.
Scroll.
It's a completely different concept, right? On the one hand side, you want to compile Java into WebAssembly, and to make use of some of the advantages that I'll be showing later in the presentation. On the other, but then you maybe need to restrict your Java, the things that you can do, the features, the functionality that you implemented. And on the other hand, it's way easier to get started because you can directly run your Java application in a WebAssembly enabled JVM. Yeah.
What about like typical microservices frameworks, like you've got Micronaut and others? Could they work if maybe you ran through Graal and turned them into Wasm or something? I don't know. We're the home of Micronaut, by the way.
I would assume that most of these frameworks are not possible to run or compile into WebAssembly, but this is just me guessing. Yeah.
Is it not safe to say that if you compile the Graal VM, you can also compile it to Wasm?
Yeah, that's what I'm thinking.
So
So if you can build an application and create a native image, regardless of framework, can that native image be compiled into WebAssembly?
I think so. Yeah.
So in that case, the answer is yes.
Okay.
You can create a native image with Micronaut or Quarkus. And
Quarkus
then
or-
there's, well, I have no idea.
Or
if that would
Spring
actually
or
be-
whatever you use.
I don't know if that'd be a good experience.
I don't know.
Yeah. And also maybe dependent upon what parts of the frameworks you're using, right? I mean, if it's something that,
Libraries are using,
yeah, if it has some kind of like multi-threading,
you're going through multiple filters, right? Because even Graal VM, not all framework features work nicely.
Right.
Yes.
Going further step.
yeah.
Right, because there's things you can't do, right? Like reflection doesn't work.
Exactly. Yeah.
Hibernate doesn't work.
Yeah, yeah.
So there'll be,
Yeah.
that would be limited feature sets.
Okay. But that's why we created these frameworks, is we're going to create frameworks that can work in a native.
Yeah.
Yeah. And I
Well,
guess
part of the reason I get at this is the month before we talked about how the JVM bytecode actually looks like.
Okay.
And how it looks. And one of the things in the Java world that we talk about is slow startup times to warm up the JVM.
Mhm.
And sometimes, it's got to validate all that bytecode for the JVM runtime. And I'm wondering if Wasm might actually have better performance characteristics and things like startup time.
I'll have a couple slides
Cool. I'd like
for
to see
you.
how they
Yeah.
compare.
Yeah. Okay. So then, yeah.
Go ahead.
No question?
That's good. Why Wasm on the server? Let's
Yeah.
talk about it.
Okay, so why then WebAssembly on the server? One of the first aspects is performance. So there, there's a evaluation that these guys from Spies and Smog did in 2021. What they did is they compared like a native x86 64 app compared to like a WebAssembly application. And the point that I want to make here is that Wasm was only 14% slower than the x86 app. And why is that the case? Oops, I'm sorry. The reason is, it was close to near native performance. The reason is that WebAssembly needs to have a runtime available, so it adds an additional layer. But it was close to the same than if you compile to native application on the environment. This is single-threaded applications that we're talking about, right?
So is that tested in Electron or Playwright or what?
That I would need to double check. I have the source here. I don't know. I need to double. I don't know.
Fine.
So then, what about WebAssembly applications where it's short-running workloads in containers? So what they did, again, here's the link to the paper that they referenced. They compared like a simple application reading a file and perform some actions on it. And the WebAssembly runtimes in this case were 10 times faster than Docker running the same application from cold start. And they usually performed in other applications that they tested, they usually performed 10 to 15 times faster than the same containerized app on WarmStart. So quite some interesting numbers. Sorry, question there?
I'm just saying that's pretty good.
That is pretty good, yes. It gets even better. So then, what about if you compare, like, WebAssembly containers versus typical, other containers, Docker containers? So in this case, again, they had like a simple HTTP server that would listen for requests and provide, response, based on the call to a database. And they had like 50 concurrent clients making these requests. And in this case, the WebAssembly application showed a worst case latency of about 15 seconds. And the Docker containers showed a worst case latency of 0.8 seconds. So huge difference there. The reason is, of course, the main reason is that WebAssembly has lack of support for multi-threading. What Docker typically does, it spreads out in additional threads and increases the CPU utilization. And, it, adds to the benefit of, having multiple containers currently running a single-threaded application. So that's just by the nature of running these WebAssembly applications for that specific use case, right? When you have use cases where, you have to rely on, multi-threading applications, then this is one of the things that you would probably need to look into deeper. Then what about when you compare WebAssemblies, based on the cold start times? So in this case, again, they had, a couple different applications that they tested, and in the modern setup where it's, common to have multi-threading handled by WebAssembly runtime, the cold start time of the WebAssembly container was about 160% faster than that of the Docker container. And why is that the case? The reason is that the WebAssembly containers are much smaller, in the region of 80% smaller than typical containers. They get never packaged with an operating system as you do with typical containers, and that reduces the volume required to pull the container, and of course accelerates also the download speeds. Oops, did I skip one? No. And then there's a company, I'm not sure if you heard about Size, a German company. If they build like not microscopes, like if you telescopes and build glasses, that's what they're known for. And they did a lot of tests and looked at the density of WebAssembly applications in Kubernetes. And what they found is that typically when running typical containers, they had this a huge win when it comes to like the size of the WebAssembly applications. They were able to get from 423 something megabyte down to 2.4 megabyte just by leveraging WebAssembly in these use cases. And of course, based on this, they had 50 times greater workload density per Kubernetes node, so they could run way more applications on the similar size nodes that you have seen previously. So huge improvement there when it comes to the pure size of running these WebAssembly applications. The next question, and I'm working for New Relic. I'm also considering how you can observe WebAssembly applications, because that used to be always an issue when you look into just like the browser-based WebAssembly applications. So what is it that you can do when you want to observe what is happening, from a tracing perspective in your WebAssembly applications? You making calls to other WebAssemblies, or your WebAssembly application makes calls into other systems. So how can you observe this and make sure that you know what is happening? And one of the things that really shines there is OpenTelemetry. Have you all heard about OpenTelemetry before?
Yeah, we had a presentation on that.
Perfect.
She
Okay.
mentioned it. Yeah.
Okay, then I can probably skip the high-level introduction. But basically, we at New Relic, we also build agents for various languages, including Java, .NET, Ruby, and so on. And we collect, telemetry, metrics, traces, and logs from these. But our agents only, of course, work with the New Relic platform. And this is where OpenTelemetry comes in. It has it's an open standard, vendor agnostic. They have also agents for various languages, APIs, SDKs, and so on, and they combine also the collection of traces, metrics, and logs into a single standard. You probably also have heard about the OpenTelemetry collector then that you can run that typically helps you to, in this pipeline, collect the data, receive the data from your applications written in various kinds of languages, including cloud vendors where you can pull and receive some data or other sources. You can then typically have some kind of processing function that allows you to process the data before you export the data to some observability backend. Like New Relic, for example, we have also an OpenTelemetry endpoint that you can use to export the data, but you can also use open source tooling, JUG for tracing, Elastic for logs, or some other tools. So you have really full control over what happens with the data that you collect. And so WebAssembly and OpenTelemetry. So Wasm Cloud, I mentioned it earlier, they already have support built in for OpenTelemetry in their environment. So when you enable OpenTelemetry as part of their platform, you can typically, if you run it on-prem or in their SaaS service, there's a configuration item that allows you to enable OpenTelemetry or observability in this case, and then define also, where you want to export the data to. So kind of like this pipeline, this OpenTelemetry collector that you have seen. If it is enabled, you can then export the data to one, OpenTelemetry collector or send it off to an OpenTelemetry observability backend. How does that look like, for example? And in this case, this is a Blazor WebAssembly application. This is the backend of the application. In this case, I have two different components. I have a WebAssembly front end that is running in the browser. I have a WebAssembly backend that's running on the server on some host here. And you can see, how the calls are being traced from end to end from your front end to the backend, including the infrastructure component. Spin. We talked about this earlier as well. Spin and OpenTelemetry, they also have built-in capabilities for OpenTelemetry. This is an example where they use .NET Aspire. Not sure if you heard about this, probably not, but it's kind of like a developer dashboard that also uses OpenTelemetry. And you have if you run it locally, it provides an OpenTelemetry dashboard that you can use on your developer machine, which is nice during development process. They have, and their OpenTelemetry implementation comes with automated instrumentation done by Spin. You may know that OpenTelemetry typically comes in two flavors, automated instrumentation or zero code instrumentation, where you don't have to define what it is you want to capture. It uses automated instrumentation of your apps in Java, bytecode instrumentation. And the other option is manual instrumentation, where you need to embed some SDKs and frameworks into your applications. There's pros and cons for both aspects, but Spin already comes with auto instrumentation, which is fine because you don't need to do anything to get good visibility into your applications. And if you then want to get deeper visualization into your apps, you can add some manual instrumentation to really define in code, then your own custom spans or some custom metrics that you want to observe. In this case, when it comes to Spin, they have this concept of an hotel plugin that you can use. Again, we looked at the Spin CLI. So in this case, there is a command to kind of like update the plugins and then install this hotel plugin that you can use in combination with Spin. And then in order to use this plugin, in this case, again, I'm using the .NET Aspire dashboard. I built my app, and then I can run my application with this hotel plugin enabled. So this is one way to basically enable OpenTelemetry instrumentation using Spin and their automated instrumentation. So in summary, we looked at a couple different aspects when it comes to the history and definitions from Wasm, the design goals, and the Wasm system interface. I showed a couple examples on what Wasm runtimes you can use, Docker and Wasm, Spin, Wasm Cloud, Wasm Time and Golem. Some of the reasons on why WebAssembly is really interesting aspect, performance, cold starts, the density that we looked at from a pure sizing perspective. And then when it comes to observability, open telemetry, in my opinion, is really the future of getting telemetry from your applications. And I showed two different examples for Wasm Cloud and Spin on how you can use open telemetry with WebAssembly that you can use. And with that, you can use a sign up for a Relic account if you want to. But I open it up for any other final questions you may have, and that was basically my presentation. Thank you very much.
Thank you, Gary.
So,
All right.
Oh, I got some.
We got to use mic because we do have
Oh, yes.
recording and folks online.
So if I'm trying to get like an isomorphic application, so I'm using the same language server side and client side, what are my language options?
If you're using the same, sorry.
Client side and server side. So I'm getting an application that's going to run in the browser, but it's going to talk to some backend web services
Right.
as well, right?
Yes.
And I'd like to use the same language on the front end as I use on the back end. What are my language options?
So basically, if you want to compile your, you are free to use whatever combination makes sense if they support, the communication between the client and the server side. So you have to have, capabilities to make REST calls or, some other ways of form of communication from the front end to the back end. But if that is the case, it really doesn't matter what languages you use on the front end, on the browser, or on the back end.
Okay, and on the front end of this, I understand, see inside the browser, you've got a runtime to run your JavaScript.
Yes.
Right? And then you're going to have a runtime that's going to run your Wasm. And apparently the two runtimes can talk to each other somehow. There's some interoperability so
Yes.
that you can do the computationally intensive tasks in Wasm. But for display purposes, you're going to use JavaScript to manipulate the DOM inside the browser.
Exactly. Yeah.
And that's the idea, at least on the client side.
Yes. Yeah. That's exactly what happens. You have some JavaScript interop that allows you to change the DOM or do some actions. But basically, when it comes to the server side, you would typically have some form of REST HTTP communication, and then it really doesn't matter what language you use there, because it will expose some endpoint, and whether that is implemented in Java, .NET, Rust, whatever, doesn't really matter.
That could be.
Yeah.
Are there good books available to introduce people to this?
There is actually a pretty good book that I used also, beginning of the year as a preparation. I can definitely put the links into the slide deck after. I don't have it added yet, but I can definitely add that. Yes.
Okay. Because I'm thinking of like learning resources for someone who's new to this. I mean, you've got the standards are all published on the web, but you probably don't want to read reference documentation. You want a tutorial or something.
Yes. So the book that I mentioned is actually also available on Manning. So if you have your discount codes, you can get this. And I think it should be published by now. I had a whatever they call it at Manning, pre-release access. While the author is writing the book, you can already look into some chapters. And I think it should be published by now. So I can definitely send the link.
Okay. You mentioned that there is a proposal to add threading. Do you know what the status of that is? How many years away?
I have no idea. I have no
Okay.
idea.
But I believe we have shipped Wasm, it's Wasm 3.0
Yes,
recently.
please,
What's in that?
I also just looked at the announcement. I forgot all the aspects, but I can maybe also add this the link to there's a nice blog post out there where they explain like some things that they shipped in 3.0. Yeah.
Well, those are my questions.
Okay. Any other questions? Anything from online, Ted?
I don't see any. I'll go look again. Please, if you got a question online, please post it in the Q&A.
Seeing, yeah, this is, thank you.
Yes.
Yeah.
You didn't come all the way from Germany just for this, man.
No.
You're going somewhere else.
Yeah, I'm going somewhere else. Yeah. So
I'm
I'm
tour.
pretty much a little bit of a tour. I'm going to Boston on have an event on Monday in Boston, Tuesday and Wednesday in New York, and Thursday in Philadelphia. Yeah, try to leverage as much events when I'm coming over here as possible.
What kind of adoption are you seeing in your developer relations role? Like, are people using WebAssembly? Is this a thing? Is it still kind of a exploratory technology? What does it look like from your vantage point?
So one of the examples, the company size that I mentioned already, they are using it in production. So there are definitely some use cases where when it comes to, running things in, as efficient as possible, or running WebAssembly modules on edge environments where density, speed of running these applications is key, makes sense. So there's definitely some really interesting use cases. But I think for the rest of the typical, applications that you build for, the typical data manipulation application, I don't think that's really a good use case. Yeah. But there's definitely some exploration out there that is happening. Yeah.
All right. If there's no more questions, I think we can. Oh, another one. We generated their question, Bruce. Okay.
Now, this is more of a comment. I think it would be interesting to do some benchmarks and see what it would take to get like a Micronaut application. If you can compile that into Wasm, like you said, I wonder what the
all I
is
said
on
is
the
you
road.
compile it into a raw VM native image.
Yeah.
If you can go from a native image to WebAssembly,
Yeah.
but I would imagine some of the limitations you talked about, like multi-threading or whatever, that's going to become a bottleneck.
Yeah. So these runtime systems are very heavily dependent on having a multi-threaded environment in order to get their performance.
You had something?
I was just going to say, it sounds like a very different use case.
Yeah.
Things like Quarkus and Micronaut are your backend REST API. WebAssembly is front end. I mean, I just like poking around on the web here, gaming, like browser-based gaming, CAD systems. I found an article on, Jupyter notebooks, which is kind of interesting. So I guess some of the components for Jupyter notebooks compiled into WebAssembly for that speedy access. So yeah, it sounds like kind of very different use cases. So.
It very heavily depends on the use case that you're putting out there. I mean, your typical, Java application is probably not a good use case to compile into WebAssembly.
But what about my front end dev hat on? Is this a situation where, as opposed to, because with JavaScript frameworks, we already have rich clients. That's a thing now, right? Single page applications, what have you. Is this a replacement for that? Is it something you're going to incorporate into a Angular or React or whatever you're using, Vue.js? Is this going to be like a selective technology, or is it like we could build our whole UI in WebAssembly and just do that?
I guess you could build a UI, an entire UI in WebAssembly, but whether that makes sense, I don't think so. I think when it comes to speed, like the gaming that you mentioned, or some high graphic things that you want to do in the browser, where JavaScript is probably not performant enough, that is probably something where you could then offload the computation into a WebAssembly component and then render just the result of whatever you did in WebAssembly using JavaScript on the front end.
for WebAssembly? Is that a thing? I seem to recall hearing about that.
I have no idea.
Okay, like machinery type things. I might be just making something up. I thought like Brian Sutter or someone gave a talk or something like that, but I could be, don't quote me on that. We'll edit the recording. Anyways,
Well, it almost makes me wonder if you could convert a Java FX or a Swing application.
Yes.
okay.
Because you're replacing, you're doing what a Java applet used to do before they took them out of the browser.
Yeah. I think that would be a really nice use case for JUG, because they come with like a user interface layer as well, right? Which WebAssembly does not. So, yeah.
Okay, so for the record, I did not make that up. TensorFlow.js does have a WebAssembly backend.
Okay.
So you could do machine learning with WebAssembly. Machine learning models in front end.
Or maybe, I don't know, run like a small language model.
That's what I'm wondering. Like, is that, I'm sure someone must have tried that by now.
Yeah.
That would be interesting. I don't know if it's a practical use case, but it'd be a fun thing to try. Cool. All right. Well, thank you, Harry, once again. Appreciate the presentation. And I think we're going to move on to our wrap. Are we just doing a straight giveaway this time? Like,
Yeah,
What do we
so
have?
we're gonna need to end the recording here.